We're going to try a couple more practice problems with the substitution method. And so I put on top here essentially the 3 steps you want to think about when you are solving by substitution. Step number 1 is we do need to solve for at least one equation for one variable. In other words, either an equation has to be in x equals or an equation has to be in y equals form. One of the equations has to be in either x equals or y equals form, and if they're not, we need to first solve one of the equations to get it into x equals or y equals form. Step number 2, we're going to then think about that $20 versus $4 or $5, kind of trading one out for the other. That was the analogy I used. If you're getting change for money, you want something that is equivalent. So we're going to substitute one expression into the other equation for the variable that it is equal to. So substitute the resulting expression from step 1 into the other equation to replace the variable, and then solve the equation. And then remember, we need 2 values in our solution, an x and a y. So the last step is to substitute the value from step 2 back into the other equation and solve for the other variable. So we have the x and the y, and write the solution as an ordered pair. An ordered pair, we mean an x, y value pair. Think of it as a point. All right, so solve each system of equations using the substitution method. Check your answers by graphing each system on Desmos. So we're going to check our answers by graphing, but we're going to do the original system with the substitution method. All right, so notice our 2 linear equations that we have here. One of the equations is in y equals form. Y equals 4x minus 6, so it's y equals mx plus b form, which is great because that means that step 1 is already done for us. Now we move on to step 2, substitute the resulting expression from step 1 into the other equation. So what we mean by that is, remember, y is equal to 4x minus 6, which means I can substitute this in to the second equation for the y value. It's like trading out the $20 for 4 $5 bills. So we're going to do that step, and we're going to rewrite that equation so we can see that substitution step done. All right. So I'm going to rewrite that second equation, 5x plus 3, and then we're going to do our substitution there. So instead of 5x plus 3y, remember we're putting 4x minus 6 in for the y. We're replacing the y with that. And that is the substitution step, equals -1. So we're just rewriting that equation with that substitution step done. Okay, so now we can go ahead and start to do a little bit of that process that we were doing on the previous page and really just solve this equation, right? And you'll have the same steps pretty much every single time here. In other words, you'll usually have a distributive property step to simplify. So 5x plus, 3 times 4x is 12x. 3 times -6 will be a minus 18 equals -1. Okay, so we have that substitution step. And then we have some combining like terms to do. So in this case, our x terms are sitting right next to each other. So combined, meaning just kind of add those together. So 5x plus 12x would be 17x minus 18 equals -1. All right, going to change colors here. All right, and then we are going to now think about just our solving steps. So now we're going to undo that minus 18 from the left side equation and add it over to the right side. So we'll add 18 to both sides of the equation, which gives us 17x left over on the left side, and -1 plus 18 is also 17 on the right side. Say 17 times what is 17? So you guys do this one in your head, but 17 times 1 is 17. And of course, algebraically, to see that is we undo the multiplication by dividing both sides by 17, and we get 1x, or just x, is equal to 17 divided by 17, which is 1. All right, so we got one value. All that was step number 2. Now step number 3 as we need our y value. And what I would recommend here probably is that we bring down the equation that is a little bit easier to substitute back into. And in this case, since we're trying to get the y, it's probably that y equals equation that we will use. So y equals 4x minus 6. And now we know that the x value is 1. So y equals 4 times 1 minus 6. All right, so 4 times 1 minus 6, well, that would be 4 minus 6. 4 times 1 is 4. 4 minus 6 is negative 2. So y is equal to negative 2. So our solution should be 1 comma negative 2, the ordered pair, the x and the y value of 1, negative 2. Let's go ahead and check our answer using Desmos, and then we'll drop that into our page here, our notes, and just double check that we did this correctly. You should do this every single time so that you're noticing whether you've done the problem correctly. So let's type in our two equations. So y equals 4x minus 6 was the first equation. And then our second equation was 5x plus 3y equals negative 1. Okay. Just going to widen this out. Let's see. Touch on the intersection point. Looks good. 1, negative 2 was our solution. So now we've confirmed that. Screenshot that. Crop it up. And we'll bring it back over to Notability. Drop that in here. And there we go. You can see our solution is 1, negative 2. We solved it algebraically, and now we can also see that is where the lines cross on the graph. All right, let's try one more. All right, now notice in number 2, both of these equations are in y equals mx plus b form. So in other words, they've both have been solved for either x or y, in this case for y. And so that's great. In fact, graphing this on a grid would be a little easier because we can kind of see the y-intercept and the slope, but we're going to use the substitution method. You could use either equation for the substitution now. I just usually like to use whatever one comes up first. So since y is equal to 5x plus 7, that means that I can trade that out for the y value. In this case, the y value is over here on the left side of the equation. So I'm going to draw the arrow over there, and then I'm going to make that substitution step. So 5x plus 7 now goes in place of the y, and I don't know what color should we pair up with that. It's kind of a hard choice, actually. All right, equals 3x minus 5, so I did that substitution step. Okay, so now we just have to solve this equation for x. Notice now we no longer have a y, we just have the x. And so we're going to go through our solving steps. Now our solving steps for this one's a little bit different because notice I don't have a distributive property on this. I do have some combining of like terms, but you'll notice they're on opposite sides of the equation. I've got a 5x on the left side and a 3x on the right side. So I'm actually going to have to undo it from one side, undo one of the x's from one side and move it over to the other. I'm going to choose to undo the 3x from the left side and then bring it, 3x from the right side and bring it over to the left. The reason being is it's going to still give me a positive x value. So it cancels out over here, and then 5x minus 3x is still positive 2x plus 7. And then I do have a negative 5 over on the right side. If I had subtracted 5x from both sides, that would have been fine. Just then I'd have 3x minus 5x, and I'd have a negative 2x instead of a positive 2x. I just like positive numbers when possible. Okay. Now I hope you see that this is basically just a two-step equation to solve for x. So if we are getting x by itself, hoping we're seeing now that we can subtract 7 from both sides to undo the adding of 7. Bring down what's left. That gives us 2x. All right, be careful here. Negative 5 minus another 7. Means you're at, think of like -5 degrees and it goes down 7 more degrees, so you're at -12 there. All right, so 2 times what equals -12? You're doing this one in your head, maybe. Mathematically, algebraically, to undo multiplication, we divide. And so 2 times what equals -12? 2 times -6 equals -12. -12 divided by 2 is -6. All right, so just like before, we have our x value for our solution. Now we just need our y value. And so now we go back up and we have to choose one of the original equations to get our y value. And we just substitute that x value into one of the equations. In this case, either one of them would be fine because they're both already set up as y equals. I'm just going to go ahead and use the first one. So y equals 5x plus 7. Now I know my x value is -6. So y is equal to 5 times -6 plus 7. And now let's just think about that. Okay, so 5 times -6 is -30. -30 plus 7 is -23. So it's going up. And now I have my y value. So in this case, -6, -23. So hopefully we did everything correctly there, and we have -6, -23 as our intersection point between these two lines. Once again, though, we're going to double check this, and I would like you to do this every time on your own so you can see if you're doing the problem correctly. So we're going to check this by going over to Desmos. We're going to drop in these two equations here. Again, our two equations in this case were y equals 5x plus 7. And second equation, y equals 3x minus 5. Okay, so chances are on this one, you are going to have to kind of mess with your window a little bit because you probably, with those negative values, aren't going to see the lines cross. So we're just going to kind of adjust a little bit. And then if you just click on them, you should be able to see where they cross. So -6, -23, that's good news because I believe that was our solution. So we'll screenshot that. If it doesn't turn out to be your solution, double check that you entered in the equations correctly into Desmos. That would be the first thing because it's very easy to mistype an equation into Desmos. So double check that. And if it looks good, maybe you did an algebraic step wrong. And unfortunately with this method is oftentimes there's just little algebra errors that we can make that then make the whole solution turn out to be a little different. So you have to be a little bit careful with your algebraic steps when you're solving the equation, just to make sure that you're being good mathematicians all the way through. And sometimes we make mistakes, and that's not a problem. We just have to kind of go back and see if we can figure out where we made our mistake and fix it. Okay, so now we can see our solution where they cross is at -6, -23, and that is what we call the substitution method.